For lesson 3.3, the Ready, Set, Go. The Ready portion is getting us to practice with tables and finding a point of intersection. Really, it's a matter of us taking a look at values and being able to plug them into the appropriate equation. So we need to plug their values in to find the answers. For number 1, we're going to plug each of these values in to this equation. And it's going to go pretty quick. Hopefully you get what I'm talking about. So plugging 0 in, 3 times 0 is 0. 0 minus 5 is negative 5. 3 times 1 is 3. Minus 5 is negative 2. 3 times 2 is 6. Minus 5 is 1. 3 times 3 is 9. Minus 5 is 4. 4 times 3 is 12, minus 5 is 7. For the g of x function, plug in 0, you get 1, 2, 3, 4, and 5. We're just taking that x plus 1. So what we need to look for is where the coordinates are the same. Circle the lines, or circle the points of intersection. Well, 3, 4, and 3, 4 are the same. That's where your point of intersection is. That's where those two lines are going to cross. For number 3, same process. Plug in a 1, you get negative 1. Plug in a 2, you get 2. Plug in a 3, you get 5. Plug in a 4, you get 8. Plug in a 5, you get 11. For the g of x function, plug in 1, you get 4. Plug in 2, you get 2. Plug in 3, you get 0. 4, negative 2. 5, negative 4. And looking for your point of intersection should be right here. For the set, true or false? All linear functions are increasing. That is a lie. False. What about when you have a linear function that's going down? It's decreasing. Arithmetic sequences are an example of linear functions. True. Exponential functions have a domain that includes all real numbers. That is going to be true. There might be some ways around that. Number 8, geometric sequences have a domain that includes all integers. False. Not necessarily. I'll let you go back and look up what a geometric sequence is. The range for an exponential function includes all real numbers. We'll call that true. No, we will not. Thinking about it here. Graph some exponential functions and try to figure that one out, where I'm saying that it could be false. All linear relationships are functions with a domain and range containing all real numbers. I will say false here, and I will encourage you to look back at one of the previous lessons where we have a linear relationship that doesn't contain all real numbers. For number 11, we are looking at domain, just domain. That's it. The domain for number 11 will go from negative 4 to 0, from 1 to 3, and from 4 to 5. Whoop. It's one of those discontinuous relationships there where we've got those gaps to contend with. For number 13, Notice that we've got an arrow and a circle. So that arrow tells me that it's going to go on forever and ever and ever and ever. Negative infinity. And it's going to go all the way up to 3, but doesn't actually touch 3, that open circle. So our open parentheses tells us that it will go all the way up to 3, but not actually touch it. All right, hopefully this helps. Let me know if you have any questions.